Alright, we're going to make this terrible experimental write-up into an excellent experimental write-up. When you look through this horrible headaches experiment, I want you to realize all the things wrong with it. I'm going to go through each of the sections of the scientific report, tell you what is wrong with Mr. Dog's scientific report, and then tell you the things you need in order to fix it. Afterwards, you will be able to rewrite Mr. Dog's scientific report on horrible headaches and produce some quality work. Alright, so let's look at the title of this scientific report, and let's write down things that make a good title. So, unfortunately, horrible headaches is a fun title, and a good scientific title isn't fun. A good scientific title is informative. So, a good scientific title is informative, and it's not necessarily fun. So, alright, so the aim of a scientific experiment is really designed so that you can let the person reading your scientific report understand what you're trying to do in this experiment. So, scientific aims always start with the word to. And the second word of a scientific report, aim, is a verb. So, there's an example given to you for what your verb could be, and it's demonstrate. Other verbs you could use are show that, investigate, find out, model, and so on. So, aims of scientific reports start with the word to, second word is a verb, and then they explain what it is that they're trying to find out. Next is the hypothesis, and the hypothesis of a scientific report is your educated guess about what is going to happen. So a hypothesis is never wrong as long as it's structured well. And ways to structure your hypothesis correctly can vary. A way that I like to think about a hypothesis is writing an if-then statement. So in this case, of the horrible headaches experiment, it might be something like, if a tablet is broken up into smaller pieces, then it will dissolve faster. You could write a hypothesis without an if-then statement, but you need to write it as a statement. So that is, you're not really saying what your feelings on the matter are. Instead, you're saying one of the options for what's going to happen. And later on, you'll see that your hypothesis can be proved incorrect, but it's not a wrong hypothesis as long as it's based on some kind of background information. It's an educated guess. Alright, moving on to the materials. There are lots of strict guidelines for how you need to write your materials list. But they're quite easy to follow and also I think a bit straightforward. So the first thing in your materials list is you need to have dot points. So you also need to write down the specific number of materials that you require. And you need to write down the size of the materials required if that's important, like the size of the beaker being used. It's also a good idea to make sure you list all of the materials needed. And that's a little bit different to the scientific diagram, where you're not going to draw everything even though you've listed everything. And that brings us to our scientific diagram. So a scientific diagram is meant to help the person doing the experiment know how to set it up. And there are quite strict rules for drawing a scientific diagram. The first is it needs to be done in 2D. They don't like 3D drawings in scientific diagrams. And the next one is no shading. Scientific diagrams aren't meant to be artistic. They're meant to be simple representations. When we do our scientific diagrams where possible, we should be using the scientific symbols for the equipment that we've learnt. The next thing we need to have in our scientific diagram are clear labels. We need to only have the setup experiment in our scientific diagram, and we call that the apparatus. So in our Mr. Dog horrible headaches diagram, you can see that he's drawn the box of Panadol, and that's not necessary. Where appropriate, you should use a ruler in your scientific diagram, just for neatness. And that brings us to the safety part of a scientific experiment. The safety of the scientific experiment should be what might go wrong and what you're going to do to avoid it. So the risk and the precaution that you're going to take. And an easy one for this is usually safety goggles or gloves. So the types of variables are listed here, and you may know how to fill this in, but I'm not going to cover that in this video. So if you know what the independent, dependent, and controlled variables are, then you're welcome to fill that section in. The next section that I'm going to speak about is the method. So the experimental method, like the scientific diagram, has some very specific rules about it. The first one is it should be in numbered steps. And when you are writing your method, it needs to be in order. So a word for that is sequential. So it's numbered, it's sequential, and just like our aim has a verb as one of the first words, in our method, the first word should be an action word. So I'm going to write verb to represent what type of words should go at the beginning of a method. Numbered steps, sequential, a verb. It needs to be able to be replicated by another person doing it. And that means that it has to have all of the steps clearly articulated so somebody else could do it without asking you any questions. And so finally, if it needs to be replicated by another person, all the steps need to be there. And if you do all of those things, then your method will be a very good experimental method for an experiment. Alright, so down to the results section of our scientific report. I'm not going to go over how to graph correctly in this video. That is going to be quite difficult to explain in a short amount of time, so I'll dedicate an extra video to how to properly graph results. What I will do though is talk to you about things you should do to have a good table for your data to be put into. And it's always a good idea if your table is drawn up before you start an experiment to make it easy to record your results and not just do them on a scrap bit of paper that you might lose. So a good results table has a heading that is informative. It has subheadings for each of the rows and columns. It has units in the subheadings and not in the individual cells. So in the individual cells of your table, only numbers should be included. There's no point writing degrees Celsius 30 different times when you can just write it in the subheading and save yourself some time. And the last thing you need for your table is to use ruled lines. And it's a good idea to do it in pencil, but that's not a requirement. It just saves you from having to restart if you make any mistakes. Alright, we're down to the last two. So the next section that I'm going to be giving you hints for is the conclusion. And lots of teachers have a way of doing conclusions. The main thing is that you're trying to communicate with the general public what you found out and how that relates to what you wanted to find out. So you're always trying to link to the aim in a scientific conclusion. After you've written a sentence restating your aim, but now as a sentence that will probably have the words successful or unsuccessful in it. I successfully showed that. I unsuccessfully demonstrated how. The next thing you're going to need is to talk about the results in general. And that could be the trend of data, or it could be talking about a comparison between the highest value and the lowest value of your data. So after you link to your aim, state your general results, then you're going to try and relate that to why it's important. So I like to write the word concept shown as the hint towards this, and it's okay if you don't know a lot about the concept that's been shown. You can just restate your aim in another way to make the conclusion one nice paragraph. So science concept shown is how you will finish up your conclusion. And you might notice, if you've been taught by me, that this actually is our ARC conclusions, and that's just because the letters of the main thing you need in each sentence are ARC in order. ARC, ARC conclusions. And finally, the scientific discussion. And finally, the scientific discussion is talking about these three science terms. So I'm just going to quickly go over them now. So, was your experiment reliable? Did you repeat the results? If you did repeat the results of the experiment, then it's likely to be reliable if those results are similar to each other. Is it accurate? An accurate experiment uses precise measuring equipment, like measuring cylinders instead of beakers, or scales that go to 2 decimal places instead of just 1. And the last one is validity. I think that's the hardest one. That's got to do with it being a fair test. Did you keep things the same? That might accidentally change the results. So if we were dissolving our tablets in water, but the water was hot in one beaker and cold in the other beaker, that's something that we haven't kept the same, so it's going to influence our results. And any of those things that you didn't do, you need to talk about how you would improve your experiment by making it more reliable, by using more precise equipment, and by keeping all the things the same that might influence the results, except for the thing that you're trying to change on purpose. Alright, so going back to the top, we've talked about what things you need in order to write an amazing scientific report: for the title, the aim, the hypothesis, the materials in the diagram, the safety precautions you need to take, what method criteria you're following, things you need in a results table, what makes a good conclusion, and how to write a scientific discussion. Down the bottom of this page, all those things I've said, I've listed again, and you'll be given this as a checklist in class to look at this horrible headaches scientific report and figure out if Mr. Dog did any of the things required to have a good scientific report, and then you'll probably be asked to replicate this experiment and write up a proper scientific report that has all the correct features in it. And now you're all going to be experts at doing this, and you can always refer back to this cheat sheet to help you write an excellent scientific report.